Namaskar children. In this lesson, we are going to have a look at the past paper questions on graphs which were given to you in school on Friday. We've already started with the first question. What I've done is I've plotted these questions on GeoGebra, and we'll be talking about the individual parts of the question. So starting with question number 1, which was already discussed on Friday. Let's have a quick look at the question once again. There's going to be a lot of back and forth between the question and the GeoGebra screen wherein you can see the graph plotted so that we can answer the questions accordingly. So this is the question that we had started. We've already worked on this part. So you have already completed the table, and this is what the structure of your graph looks like. This is the structure on paper. This is very similar to what you get to see on the GeoGebra screen also, because I have tried to scale it exactly the way it is given in the question so that there is no ambiguity and no confusion. Alright, so for part C of the question, we've already discussed this. Use your graph to solve fx is equal to 0.5. What we do is, in the graph which we've plotted, what we have to now do is go ahead and plot a line which is y is equal to 0.5. So there you see, that's the way the line goes. And in order to find the solution of fx is equal to 0.5, we need to make a note of the fact that the line cuts the original curve at 1, 2, and 3 points. So since I'm working on GeoGebra, all I'm going to do is select these 3 points. So one point lies here. Then this is the second point, and that's the third point. So if I make a note of the coordinates of these 3 points, which you can see over here are I, J, and K. So I has a value of minus 2.19, J has a value of minus 0.52, and K is 2.67. So approximately, even in your graph, this is where your points should lie. This, of course, is an exact calculation, so may vary slightly between your graph, which may not be exactly as accurate as this one. Okay, so that's the answer to part C1, which we had already discussed. Part C2. Here we need to find the inequalities for k so that fx is equal to k has only one answer. Now, even when I was trying to do this in class, there was a little bit of a confusion about what is k. Is k the value of x or is k the value of y? Now, in all such cases, go back and read the statement which is written and you will immediately know what it means. Here, the question says fx is equal to k. Fx is the function which is plotted. Fx is all the values on the y-axis. So which means here we are talking about the value of k which lies on the y-axis. But we are interested only in those values of k for which there is exactly one answer, only one solution. So for this, we need to again look at our graph carefully. So there you go. That's where our graph is. I'm going to just draw 2 lines and then explain the concept of what this one solution exactly means. Okay, trying to orient a little. Yeah, maybe this one and the second line. Here, and just trying to make it a little straight. So that's the way it is. All right. So as I explained in class, between this line, this is line M, and the second line, which is line N, all the lines which will be drawn in between this range will obviously cut the graph at 3 points, because there's be 1 point here, 1 point there, and the third point at the last part of the curve. If we look at exactly the line M, then this line cuts the curve at exactly 2 points. One is this point and one is the other point over here. Similarly, this line beneath also cuts the curve at exactly 2 points. One is this point and one would be that point. But our question is something else. Our question wants us to find out all the values of k for which there is only one answer. So which means, can I not say that all the values which appear above this line, will all be cutting the curve only at one point, because there is no other possibility. There is only one part of the curve which actually lies above this line that we are talking about, this line M. So all the lines will be cutting the curve only at one point. Similarly, for all the lines which will lie beneath this line N, it will be only one solution, because there is only one part of this curve which then is present in that region. So now, since we need to present this as an inequality, we need to look at the value of y, or rather the values of y. So for this line M, what I'm going to do is select a point. As we can see, this is the line for which there are exactly two solutions available, and this is the line for which again there are exactly two solutions. So all the values of y which appear above this line will all cut the graph at only one place, and all the values of for which the y is less than maybe a minus 3.8, it'll cut the curve only at one point. So that's how we can say that the answer to this over here, inequality, there's a slight error here, because this needs to be less than not 3.8 but a minus 3.8, whereas all the values of k need to be greater than 1.8 in order to get one single solution or only one answer, right? So let's look at the next part. On the same grid, draw the graph of y is equal to 3x minus 2. We've discussed this in class earlier also, that on the same graph, when we represent two different functions, it is possible to find the combined solution of both the functions on the graph. So let's look at our GeoGebra version. And this line that you get to see is, this line is actually the line which you need to draw in the question. And we need to find out the combined solution of this blue curve and this red color line. So which means we are talking about the points of intersection. So we've part 3.1 is about drawing the line. So this is what we do. We just draw the line on the graph. And then the second part says that the equation, one second, I'll just show you what the second part is. Yeah, this is what the second part of the question says. The equation x cube upon 2 minus 3x minus 1. This is the curve that we have already plotted. This is the line also which we've plotted. Can be written in the form x cube plus ax plus b is equal to 0. Find the values of a and b. Now over here, all we need to do is a little bit of algebraic simplification, so that this representation of the algebraic expression can be changed to that form. So as you can see, all we are doing is changing sides and rearranging it, so that we can finally write the same relation in the form of x cube minus 12x plus 2. And by comparison, we know a is a minus 12 and b is a 2. So let's proceed further. That's the last part of the question. It says use your graph to find the positive answers to x cube upon 2 minus 3x minus 1 is equal to 3x minus 2. So which means we are talking about the point of intersection of the curve and the straight line. Both the curve and the straight line are already plotted on the graph. So what we can do is have a look at the graph and accordingly answer. So there we are. That's the straight line and this is the curve. Now a point to be noted over here is we are looking only for the positive answers. So which means we need to find out only the points of intersection for which x is positive. So when we look at the graph, one point of intersection comes here and one comes there. So for A, the point over here as an exact calculation reads a 0.17, and there for point B it's a 3.38. So as mentioned in this solution, it's a 0.2 and 3.35. So within the limits of the graph that is given, this comes out to be a correct solution. So that's the first question. And now we'll have a look at the second question. Now let's look at the second question. This is the second question in the booklet. A part of the graph is already drawn over here. Y is equal to fx and fx is defined as 1 upon x plus x square. So as the question reads, a part is already drawn on the curve, on the graph for you, and you actually need to complete this table and plot these points. So when you plot these points, you will get the other part of the curve. I'll just show you what this curve looks like in GeoGebra. You can have a look at the solution which is given here also. So this is the part which is already done, and what you see in the form of this line with a pencil is what is done on the graph later. And in GeoGebra, that's the way the solution looks like. So this orange color curve, this orange lines, on this side and the curve on that side is the original function which is plotted, and the rest are depending on the subparts of the question. So let's look at the questions now. So having done this part, yeah. So that's the table. You can cross-check whether your values tally and plot it. Now looking at part B of the question, it says on the grid, draw the graph of y is equal to fx, which we've already done. So this entire function is complete on the curve, on the graph. By drawing a tangent, work out an estimate of the gradient of the graph where x is equal to 2. So x is equal to 2 would entail this point A. So as you can see, this red color line is the tangent which has been drawn to the curve in order to estimate the gradient of the curve. I've already mentioned in class that whenever we need to find out the gradient of a curve, we always need a point at which the tangent needs to be drawn. And this is essentially because the gradient of a curve always keeps changing. It is never constant. Unlike a straight line, the gradient of a curve is never ever a constant. So for x is equal to 2, this is the point on the curve. So we make a tangent. This of course is made directly using the GeoGebra tool. You will have to do this on your graph with a sharp pointed pencil and ensure that you get a perfectly straight line. And the trick to this is to place the line in such a way that it is equally spaced on both the parts of the point. So above the point and beneath the point. This is something for which you'll have to practice a little, and then you will get the instinct of how the line can be drawn exactly accurately. And for this part of the question, we also need to find out the slope of the line. So slope of course, you know, is rise over run. So you can choose your any two random points on the line, and the value of the slope will come out to be equal to, here it says 3.75. So in your graph, it could fall within a certain range. It could be a 3.4 to a 4. And the other point to be noted is whenever you're trying to find out the gradient of a line, it is always better to choose your points at a long distance. I mean, keep them further apart and try and choose those points for which you can have exact values of the x and y coordinates, because then it becomes easier to calculate. And I repeat what I said, further away the points, the better is the accuracy of the gradient. So don't take points which are very close. That will lead to inaccurate answers. All right, so let's go back to the question once again. So there we are. The gradient of the curve is a 3.75 as mentioned over here. Now next part, write down the inequality satisfied by k, where fx is equal to k has 3 answers. So again, we have a similar question as we did in the first question also. Fx is equal to k. So we are again looking for those values of y for which we have 3 answers. So going back to the curve. Over here, as we can see, if I were to draw a line from this point and kind of orient it slightly, try and make it a little straight. It's a little difficult to do it like this without a pen tablet, but all right, I am not able to get this line straight, so I'm actually going to not take this line at all. Let's just consider this point. So a straight line which is going to be drawn parallel to the x-axis at this point, which would be somewhere around 1.9. That straight line would meet the curve at exactly 2 points. But all the lines which were to lie above that line will all meet the curve in 3 points, because 1, 2 and 3. There are 3 parts of the curve. So which means all the values of k which are greater than 1.9 will all give us 3 answers. So let's go back and see what our answer space says. Alright, so there's an error here. The exact answer will be all the values of k need to be greater than 1.9. Again, note that the inequality will be greater than and not greater than equal to, because when it is equal, we have 2 answers and not 3 answers. So for this, the correct answer would be k is all the values which are greater than 1.9. Moving further, draw the line. Alright, So we are at part E. Draw the line y is equal to 1 minus x on the grid, which is this line. So that's the line. Sorry, that's not the line. That's the tangent. This, yeah, this blue color line. This is the line 1 minus x, which is drawn on the graph. Further, what we need to do is, once we've drawn that line, use your graphs to solve the equation 1 minus x is equal to 1 upon x plus x square. So this is the curve which was plotted earlier. This is the line which we've just drawn. So the intersection of the line and the curve will give us the solution. We're looking for the x coordinate of that point of intersection. So let us go and check. We have the point of intersection here in the form of B, and the x coordinate of B is 1.8 minus 1.84. So yeah, so that's what the solution also says, minus 1.85. Next part of the question. Rearrange this expression into the form 1 upon x plus x square is equal to ax plus b, where a and b are integers. So over here again, it's a similar thing which we did in question 1 also, but this is looking at it the other way around, because here the expression is given and we need to rearrange it so that we get the curve is equal to a straight line. Now over here we obviously don't know the values of a and b, so as I said, this is nothing but a case of algebraic simplification. All we do is change sides, left hand side to right hand side or right hand side to left hand side, and see how we can manipulate the given expression to rearrange it in this format. So once it is rearranged, this is what we get. So this is the curve which we've already plotted, and this of course is the equation of a straight line. Next part of the question, write down the equation of the line that could be drawn on the graph in order to solve x cube minus x square minus 2x plus 1 is equal to 0. So this is the expression which was given. So in other words, this is a roundabout question, because what they're trying to say is they're asking you the line which needs to be plotted so that we could have used the same curve to get the solution for this cubic expression. So as we can see, this cubic expression is the curve is equal to the straight line x plus 2. So the answer is that we need to draw x plus 2 as a straight line on the same graph which already has the curve, so that we can find the solution for this cubic equation. So this is what is called as graphical manipulation, and we are extrapolating the graph. From the given graph, we can further find out we can solve another equation which we have not really plotted on the curve. But over here, you just need to report the final answer as y is equal to x plus 2. Now let's look at the third question in the booklet. Complete the table of values for y is equal to 2 raised to the power of x. So after you have used your calculator, this is what your values should be. A 0.5 and a 4 are the empty spaces. And then you plot this on the graph which is given. This of course is an exponential graph. When we say y is equal to 2 raised power x, it gives us an exponential curve, and this is what the exponential curve looks like. I'll show it to you in GeoGebra also. Yeah, so this pink color line is the exponential curve that we had to draw, and that's the way it looks on the graph. Let's look at the other parts of the question. On the grid, draw the straight line which passes through the points 0, 2 and 3, 8. So I have already done that part. Over here, just a minute, I'll just show you what it is. Yeah, this is the point 0, 2, and that's the point 3, 8. So we plot these points and join an extended line passing through AB. So that's the line we're talking about. This is the line that you need to draw on the curve which already exists on the graph. Further, the equation of the line is y is equal to mx plus 2. Show that the value of m is 2. So you need to find out the gradient of that line. So what I shall do is, since I'm working in GeoGebra, I can find out the gradient using the function. So the gradient of this line is a 2. So we can see it in GeoGebra, but on your graph also, as I said, you can select two random points which are placed further apart and find out the gradient as rise over run, and that will come out to be 2. All right. Proceeding further, one answer to the equation 2x is equal to 2x plus 2 is x is equal to 3. Use your graph to find the other answer. When we go back to our original curve. Now over here, if you note, 2x plus 2 is the same line which we have plotted on the graph, because the gradient of the line is 2, and of course if it passes through the point 0 comma 2, the intercept is also 2. So 2x plus 2 is the line which we've already plotted on the curve. So one solution is x equal to 3, and we need to find out the other solution. So let's look at the graph. The intersection of this pink color curve and the black color line essentially does happen at 2 points. One is this point, and that's the other point, point C. So for point B, we already know that the solution lies at x is equal to 3 and y is equal to 8. But for point C, if you see these dotted lines, the corresponding value of x comes out to be equal to a minus 0.7. So that's exactly what is reported over here also. So this answer is correct. So whenever we need to find out the solutions, the easiest thing to do is just drop a perpendicular onto the x-axis, maybe with a dotted line, and then we can very easily find out the solution. Proceeding further, draw a tangent to the curve. So we need to draw a tangent to the curve at the point x is equal to 1, and then we need to estimate the gradient of the curve also at that point. So going back to the curve, x is equal to 1, so which means D is the point, and I've already done this for you. At the point D, this is the tangent that we are talking about, and the slope of this tangent is a 1.39. So as reported in the solution, a 1.538. So close to the exact value. So that's about it for this session. So I have taken you through the first 3 questions of the booklet. Now for homework, what I want you to do is definitely complete these first 3 questions, as also solve the last 4 questions of the booklet. Now the booklet has 10 questions in totality. So you will be doing question numbers 1, 2, 3, as also question numbers 7, 8, 9 and 10. You need to complete all this and bring the entire booklet to school on Monday. Thank you very much.